right, so how can we tell if 8 is a factor of 164? How could we tell that? How, Caleb?
8 is a factor of 64, so you can get rid of that, and 8 is not a factor of 100. So
You're getting all fancy. Let's say we don't have very good math skills. Let's pretend we don't have very good math skills. I mean, I know you all do. But let's pretend we don't have very good math skills. How else could you tell if 8 was a factor of 164? How else?
Just guess. You could like a guess and check type of thing, maybe. Kind of like, I know that might take a little bit, but.
Yeah, I don't want to take a little bit. I want to be lazy. I want to be efficient. What? I don't think you're quite saying that right. Oh, wait, 164 divided by 8. So I would pull my calculator out and I'd go 164 divided by 8. That's how we would tell if it's a factor. And if it is a factor, what would I not have? Or if it isn't a factor, what would I have? How would you know? If there was a decimal answer, it is not a factor. What would we call that decimal answer after you divide it? That would be the remainder. So if there was a remainder, then there would not be a factor. Or 8 would not be a factor. So we are doing that today. We're going to divide two numbers to see if they are actual factor, if one is a factor of the other. We're going to do that today. The only problem is you can't type them in your calculator because they look like that. They're polynomials. But the process is the same. We are going to divide them and see if there is a remainder to see if x minus 2 is a factor of x squared plus 2x minus 4. How do you divide polynomials? Two possibilities. Long division or synthetic. You might have to use long division depending on what you're dividing by. But for this one, since we're just dividing by x minus 2, we can use synthetic division. So let's review synthetic division. So x minus 2, you have to find that k value. You set x minus 2 equal to 0, and x is 2. So you put that 2 outside of the vertical line in the synthetic division. Some of you on that quiz last week, you didn't set it equal to 0, and you have the wrong number here. If you have the wrong number here, everything's wrong. Then what goes on the inside? The coefficients. So we have 1, and then 2, and then negative 4. All right, and then we do our synthetic division. You bring down the 1, then you multiply by 2, and you get 2. You add, you get 4. You multiply, you get 8. You add, you get 4. That's our remainder. So is x minus 2 a factor? Not a factor because there is a remainder. Question. What'd you do? Yeah, you could. You could. I'm doing it this way on purpose because of what it's leading to our next step kind of thing. So yes, you can do it that way, but for what we're doing next after this, you might as well just practice it this way. Okay? Either. All right, so how about this one? Determine whether x plus 5 is a factor. So x plus 5 equals 0, x equals negative 5, that's going to be our k value. Then we go and we find all of our coefficients. And our coefficients are 3, 15, negative 1,
0 and 25.
0 and 25. What happens if you miss that 0? You get it wrong.
You die.
You get it wrong. No, no. So we bring down our 3, and we multiply by -5, we get -15. Add them, get 0, multiply by -5, get 0. Add them, get -1, multiply by -5, get 5. Add them, get 5, multiply by -5, get -25. Add them, get 0. So synthetic division again. Is there a remainder?
No.
So no remainder. Means x plus 5 is a factor. All right, the next one is a U-try. So you're going to set up your synthetic division. I'm going to come around and check that you have the correct answer and that your numbers look correct also in your synthetic division. So do it all the way. Everything else is right. All right, if you are ready to go on, if I've checked you up and you are ready to go on, go to the next page. Oh yeah, it's totally, yeah. It just depends on what book we're using, how they put it up, but yeah. Right, so the next kind are factoring a polynomial. This says first, show that x plus 3 is a factor, and then it says factor it completely. So if we looked at this polynomial the way it is, no, never mind. Let's just show that this is a factor. To show that it is a factor, we use synthetic division and divide it and show that it has no remainder. So x plus 3 is 0. What number is going to go right here? -3. So it's always the opposite number that's going right there. And then our coefficients will have a 1, we'll have a 3, and we'll have a 0, then a -1, then a -3. If you forget that 0, you're not going to get it right. We have to show that this is a factor. So we do synthetic division to show that the remainder is 0. Now it says factor completed. We know one of the factors is x plus 3. We know one of the factors is x plus 3. So what we're going to do is after we factor that out, we're going to see what we have left over. So left over, this 1 is x to the what? It is always 1 exponent less than the starting one. So that would be x to the third. This would be 0x squared. This would be 0x and then minus 1. I don't write the zeros in there, especially when I'm trying to factor. Not done. So it does factor completely. X plus 3 is factored as far as it will go because x is to the first power. X cubed minus 1 is a binomial. Does it have a greatest common factor to take out?
No.
So then what kind of factoring do I need to do for x to the third power? What's it called?
I don't know.
Some are difference of cubes, right? So we're going to factor it using that formula, which I'm rewriting on the board right now. And I wrote the plus version of that formula because you can just rewrite this as x cubed plus negative 1. You could also use the minus version of the formula if you want to, but then people get confused. So I just always use the plus version. So what would be my A value? To do that, I would do the cube root of this one here. What times what times what is x to the third power?
X times X times X.
Right, x times x times x. So I put x right here. And then what times what times what is negative 1?
Negative 1.
Negative 1. So I have those numbers there. This is what we did yesterday for those of you that were gone yesterday. Then we have to do the other parenthesis. And the other parenthesis says whatever A was, square it and put it in this spot. Whatever A was, square it. So A was x, square it and put it here. The middle term is minus the two numbers multiplied together. So the middle term is going to be minus x times negative 1. And then the last term is negative 1 to the second power. And then I'm just going to simplify that. You could simplify that in your head as you're doing it, but I wanted to show all the steps since we had people absent yesterday. So simplifying that, we'd have x squared plus x plus 1. Then yesterday I also told you that when you do this cube thing, that this second parenthesis with the trinomial, it will never factor further. It's factored all the way. When you do the specific cube formula, this one will never factor further, so we don't need to go and check it. Usually we have to check them, but this one is done, so we don't have to go back and check it. Oh. There you go. All right. So the next one is a U-try. Next one is a U-try. Okay, so walked around, you guys had synthetic division. That looked good on your papers. We had 1, negative 5, negative 6, and then a 0. And there was no remainder, so it showed that it is a factor. So then we write that factor x minus 6, and then we use these numbers to write the other factor, x squared plus x. And then we use our factoring from yesterday. And we always start with what?
GCF.
Is there a GCF of x squared plus x? There is one. There's an x. So we're going to factor that out. And what is left over when we factor out an x from both terms? X plus 1. Now, some of us just brought that x minus 6 down, and this kind of looks weird to me. Does it look weird? With
But
that
it's multiplication,
X in the
so
middle.
it doesn't really matter.
Right, the order doesn't matter. I mean, it's okay, but we just don't normally write the GCF in the middle.
Yeah.
We normally put it out front, so I'm just going to rearrange so that the GCF is out front. Okay? Now, before we go on to our next section, I want you to just watch for a moment. I'm going to graph this equation on my graphing calculator.
No.
I'm going to graph x times x minus 6 times x plus 1. All right. And this was odd power, so the end behavior goes from down to up. What are the x-intercepts from this picture? What are the x-intercepts? Here, I can zoom in a little bit. Hold on a second. Let me zoom in just a little bit. Just so everybody sitting further away, can you see where the x-intercepts are? What's the first one? Negative 1, 0, and 6. Negative 1, 0, and 6. Our x-intercepts negative 1, 0, and 6. Now look at our factors. Looking at our factors. If I did x equals 0, if I did x minus 6 equals 0, if I did x plus 1 equals 0, and I solved each of those, I would get negative 1, 0, and 6. That's coming from our factors. These are things we've already done, where if it said equals 0 and we solved it, you guys remember solving by factoring, we've done that before. So we're going to kind of use that knowledge now, and we're going to kind of go backwards. So turn to the next page. The directions are at the top of the page, but I've made them bigger, and I've written numbers 1, 2, and 3, so we kind of have something to follow. First thing I want you to do is I want you to find the x-intercepts of each graph below. So let's do graph capital A together. Capital A, what are the x-intercepts of capital A?
Negative 1, 0, and 1.
Negative 1, 0, 1. Notice how I write my answer in set notation with the fancy brackets, separated by commas. Or you can write every single one, x equals negative 1, x equals 0, x equals 1. Up to you if you want to do extra writing. So if I were going to factor this one, if I were going to factor it using my x-intercepts, what would be, how many factors would there be?
3.
There would be 3 factors, 1 for each x-intercept.
X plus 1, x, and then x minus 1.
Yeah. So the first one would be x plus 1. That's how we get negative 1. That gives us negative 1. The last one will be x minus 1. That's how we get positive 1. The middle, some people were doing this earlier, so I wrote it there, but I wouldn't actually write it like that. I would write it as a GCF in front. So I found the factored version of that equation. Okay, and then the last thing that you also have to do is you have to match that equation to the actual equation below. And in the directions, it says things like use the degree what is the degree of this one? There's 3 x-intercepts. It looks like this. It'd be 3. So this graph A is only going to match to any of them that have a cubed on it. It's not going to match to a square.
Well, the number of intercepts doesn't really matter, does it? Because you could have that be like higher up and only have 1 intercept.
Yes, but I didn't put any tricky ones like that.
Yeah.
We will get there. But you're totally right. And then what else? We can also look at the y-intercept. What's the y-intercept of this graph?
0.
So the y-intercept is at 0, so we could look and see which ones have a y-intercept at 0. So you're going to kind of eliminate and figure out the matching after you've done this other work. Okay? So take a few minutes, figure the x-intercepts, figure out the factoring, try to match them with the graphs below. And I'll come around and answer questions. One thing you do not want to do, and I do not want you to do, is just type it in your calculator graph. Like, we can do that, but that's not you learning anything. That's just plugging things in the calculator. I want to see if you're actually learning the material. So for E, my x-intercepts are at -2, 0, and 1. So then to factor that, each of these becomes a factor. Oops, that's not what I was trying to do. Each of these is a factor. X plus 2, x plus 0, and x minus 1. But I don't write x plus 0. Put it out in front. And if you notice that ahead of time, save you a step. So that would be the factored version of that one. For F, same thing. I'm going to look at my x-axis, and it crosses at -1, 1, and 2. X-axis, -1, 1, and 2. So then I'm going to factor it. I'm going to have x plus 1, x minus 1, and x minus 2 for the factored version. Okay, and then for matching, if you found the x or the y-intercepts, that would give you most of the matches. Most of them, not quite all of them, but yeah, there were 2 of them that were kind of tricky. Question, which one? Lowercase a, which one did that one have to match to? That one is C, because that's the only one that's quadratic. That's the only parabola. Question B has a y-intercept at 2. Y-intercept is at 2. What's question B? Yeah, is that the only one at 2 also? Yep. Question C has a y-intercept at 0. Yep, that one is E. Question D has a y-intercept at 0. It is a cubic. That one's A. E has a y-intercept at 4, so that one is D. And then we've got E left over here. Okay? So our assignment is big idea. It will be partially a factoring review, and then part of it's the new stuff. So grab a computer, you got some time to work on it. There is nobody who does not have an Algebra 2 credit. This is brand new stuff. There's none of you that are going to be able to be factoring this stuff without scratch work. So make sure that you have some sort of paper that you are working on. No.